We're continuing on with systems of equations, and we're going to do the substitution method. You've already learned that you can graph the two equations, find out where they intersect, and you have your answer. Now we're going to find another way, substitution method, which is going to be based upon algebra skills, moving around equations. So in this case, I've got two equations. If I felt like it, I could graph them. In this case, I'd probably have to convert both of them into y equals mx plus b, or work with graphing the intercepts. But if I want to, I can do a clever little trick. And the trick is called substitution, and it goes like this. In this case, x is by itself, and it says x equals 10 minus 3y. I can also rephrase that to say x is the same thing as 10 minus 3y. So regardless of how I want to think about it, I get to do this little trick. If x is the same thing as 10 minus 3y, or 10 minus 3y is the same thing as x, look what I get to do. I take this 10 minus 3y, and I go into the other equation, and I replace it, or I substitute. Okay, that seems like a weird move, but you're going to see why here in a second. So now I'm going to take that initial equation, the 4x plus 2y equals 10, and I'm going to rewrite it. But instead of saying 4 times x, I'm going to say 4 times 10 minus 3y. Because 10 minus 3y is the same thing as x, I'm allowed to write 10 minus 3y in place of the x. Be careful to put your parentheses there for beautiful Princess PEMDAS. Everything else I'm going to remain or keep the same as the original equation. So if 10 minus 3y substitutes for x, why did I do it? It's because now in this equation there is only y's. In this equation there was x's and y's floating around together. Having just one variable is good because now I can solve for that variable. I just have to be good at the algebra steps that we learned earlier in the year. My first step is to multiply out, so I get 40 minus 12y plus 2y equals 10. Now I'm going to pause this and continue out, but what I'm going to do is I'm going to solve this equation for y. After going through all these algebra steps, which you might want to practice on a sheet of paper on your own and compare to mine, I get an answer of y equals 3. Now from there, I need to figure out an answer for x, because remember, a solution to a system of equations has both x and y. So what I will almost always do is after I get an answer for a y, I'll do what I call the plug-in. And for the plug-in, what I do is I take my answer for y, and I choose whatever equation in there looks like the easiest to work with. I could choose this one, or I could choose this one. This one looks easier to work with. So I take that equation and I write it down, and then I plug in my y equals 3. This pen is running out of ink. I apologize. I'll switch up on the next example. And I get an x equals 10 minus 9, an x equals 1. My answer to this system is y equals 3, x equals 1. Now that's the first time you've seen this procedure, so it might seem a little weird. I'm going to summarize the steps. So when I look at my original system, the first thing I do is I look for substitution. And my substitution was there because x was the same thing as 10 minus 3y. After I find that substitution, I rewrite an equation with substitution. So that showed up here. This equation, I rewrote it, substituting my x. Then I'm going to solve the equation. That's what happened right here. And then finally, I'm going to plug in to find the other variable. And that's what I did right there. Now these steps can be applied to any system of equations, but it takes a little practice, especially looking for the substitution. I'm going to show you a more difficult example following these steps. Okay, I have a system of equations. Ultimately, I want an answer for x equals and an answer for y. I could graph these and see where they intersect, but we're doing the substitution method. Now, in this case, it's not easy to spot a substitution. I'm going to go back to the previous example. In this case, it was really easy to spot a substitution because it says x equals 10 minus 3y, or in other words, I can substitute a 10 minus 3y for wherever I see an x. Well, that was easy because a variable was by itself. In this case, there is no variable by itself. So what I'm going to do is I'm going to rewrite one of these equations. In this case, I see that it would be very easy to get y by itself. So I'm going to rewrite it and say y equals negative 2x plus 3. I just moved this positive 2x to the other side. This equation, I'm not going to do anything with it, but I'm going to recopy it. So what I had to do here was take a system that wasn't very friendly for substitution, and by solving for this variable, I made it into an equation or a system that's going to be friendly to substitution. Now there's nothing magical about solving for that y. I could solve for any variable in here. I just chose the one that was going to be easiest. So at that point, I can now simply say negative 2x plus 3 is the same thing as y. So I can take that and I can substitute in for that y in the other equation. It was easy to spot in this form, not so easy to spot in this form. So if I substitute, now what I get is negative 4x minus 4 times, instead of writing y, I'm going to write negative 2x plus 3. I have to put a parenthesis around my substitution so that I remember to distribute the negative 4 in there. So I've done my substitute. Now the next thing I'm going to do is I'm going to solve this equation for x, because the whole reason I substituted is so I could have an equation with just one variable in it. I'll pause it while I solve it. You should solve it too to see if you get the same answer. Hopefully you paused and worked it out as well. When I worked this out, I got x equals 1. I'm halfway there. After I've gotten one variable, I need to do the plug-in to get the other variable. When I do this plug-in, I can choose this equation, this equation, this equation, or this equation. It doesn't matter. I just need to choose one of the equations from the beginning of the problem that have x's and y's floating around. This equation is the easiest to use, so I'm going to go ahead and use that, but realize it can work with any one of these. So I just say y equals negative 2x plus 3, but I already know what x is. Y equals negative 2 times 1 plus 3, y equals negative 2 plus 3, y equals 1. I have my answer, x equals 1, y equals 1. That's my answer to that system of equations. I want to show you what would happen if I would have chosen one of these equations that wasn't what I think is the easiest. So I'm going to choose, say, this equation and do the same plug-in. You notice that using this equation, plugging in the x equals 1, because that's what I had found out for x, I solve for y, I still get the same answer that I got using this equation. This equation would have been even uglier to use, but I still would have gotten y equals 1 had I done my steps correctly. So my final answer to this is x equals 1, y equals 1. If you want to confirm that, take this, plug it into each of these equations. It should work for both of those. As a reminder, unusual things can happen. You can be working through your equations, and if you end up getting something like 7 equals 4, well, that doesn't make sense. That stuff can happen, though, in equations. If you end up with something like that, what you end up with for your final answer is no solution. That same thing happened in the graphing method. If you graphed and the two lines never intersected, you would also have no solution. Likewise, you can be working through your equations and your variable disappears, but you end up with a true statement. This is going to be an infinite number of solutions. That happened to you earlier in your algebra life when you were solving equations. And remember that if we were doing this in the graphing method, if you graphed one line and then the next line happened to graph right on top of it, they're intersecting for infinity or infinite number of solutions. All right, this is the substitution method. As you can tell, it takes a lot of computations and probably a lot of practice.